Welcome to this episode of the Informational Electromagnetic playlist. Today, we're diving into electromagnetic intelligence, a powerful concept that brings together physics, materials science, and information theory. At the heart of this idea lies a fundamental question. Can we make materials that don't just respond to electromagnetic waves, but actually process information through them? This is where smart metasurfaces come into play. They're not just passive reflectors of waves. They're engineered materials that detect, react, and compute, all through the physics of fields. Let's begin with inspiration from nature. The chameleon, master of camouflage, changes color to blend into its environment. But this isn't just about pigment. It's about how light interacts with the skin's microstructure. That's the biological equivalent of an intelligent surface. In engineering, we replicate this principle using metasurfaces, materials designed to control how electromagnetic waves behave on their surface, much like chameleon skin controls light. These materials aren't just mimicking nature, they're going beyond it. They form the basis of adaptive, programmable, and even self-aware electromagnetic devices. This is the core of the presentation. Information metasurfaces. They're more than engineered materials, they're interfaces between physics and computation. Traditional metamaterials manipulate waves. But information metasurfaces take it further, they embed sensing, logic, memory, and even reaction into a thin, subwavelength structure. These are smart materials that know how to respond based on what they sense, creating a loop of environmental awareness, decision, and EM response. This is the physical realization of intelligence, using electromagnetic fields as the medium. So what exactly is a metasurface? A metasurface is a 2D arrangement of tiny elements, often smaller than the wavelength of the incoming signal, that can manipulate electromagnetic waves in precise ways. We can tune these to change how a surface reflects, refracts, absorbs, or scatters light and other EM waves. Now imagine embedding sensors in them, light sensors, motion detectors, chemical analyzers, and connecting that input to an internal rule that changes the EM behavior of the surface in real time. That's what we call closed-loop EM intelligence. It turns a passive material into an interactive system, one that acts like it understands the world around it. Let's now look at a powerful application of electromagnetic intelligence. Ultra-short-range smart sensing using reconfigurable metasurfaces. What you see here is a multi-scale system, where graphene-based nanosensors are integrated into a programmable metasurface array. These nanosensors detect signals like light, humidity, and biosignatures, making the surface capable of real-time environmental perception at the terahertz scale. Here's how the intelligence emerges. A signal, such as light or chemical presence, is sensed locally by the graphene nanostructures. That signal is processed by a digital unit, often an FPGA, which converts it into voltage patterns. The metasurface then reconfigures itself, changing its radiation pattern depending on what it has sensed. This is closed-loop electromagnetic intelligence in action. On the right, we see a color-sensing metasurface. It uses light sensors to detect visible wavelengths, determines the color, and updates its electromagnetic function accordingly, switching between dual-beam, multi-beam, or RCS-controlled scattering. In short, this slide shows how physical intelligence is encoded into EM behavior. The material senses its environment, processes the information, and responds, instantly and without external computation. It's not just a smart sensor. It's a material that sees, understands, and acts, all through the electromagnetic field. The terahertz range offers new frontiers for communication and control. Metasurfaces operating at these frequencies can modulate and redirect EM waves with high precision. What makes this exciting is the integration of spacetime coding. This means metasurfaces not only shape space, like how a wave bends or reflects, but also time, by delaying, synchronizing, or modulating wavefronts on the fly. This is a paradigm shift in communication systems. Instead of just transmitting data, the surface becomes part of the computation and control. We move from static antennas to intelligent EM systems that shape their own signal environment. Let's finish with something bold. Could electromagnetic fields one day allow us to read the brain? Through EM holography, we might someday reconstruct interference patterns around the brain and decode them into meaningful data. Brain activity naturally produces EM waves, albeit weak. But with sensitive metasurfaces and clever algorithms, we could move toward non-invasive cognitive mapping. The final note is even deeper. We may eventually build logic gates and memory using EM fields themselves, no silicon, no wires. Just fields interacting with surfaces in programmable ways. That's electromagnetic intelligence. Not just smart sensors, but a new way of computing, sensing, and even thinking, all through the physics of light, surfaces, and space.